Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized pieces you can actually understand.
Today, we're diving into the world of medical imaging. Think X-rays, CT scans, MRIs, the pictures doctors use to see what's going on inside our bodies.
And we're looking at a paper that proposes a new AI-powered assistant for the doctors who have to read all those scans. This isn't just any tool, it's designed to be a super accurate, incredibly helpful partner in diagnosis.
So, why do we even need an AI for this? Aren't radiologists really good at their jobs?
They are, but the sheer volume of images they have to look at is staggering. A single patient can have hundreds of images from one scan. Now multiply that by all the patients in a hospital.
That sounds overwhelming. It must be incredibly time-consuming.
Exactly, and it's a high-pressure job. Even the best experts might interpret a subtle shadow slightly differently, which can lead to inconsistencies. Plus, existing AI tools often have limitations.
Like what? They're not smart enough?
It's more that they are often built for just one type of image. An AI that's great at chest x-rays might be useless with a brain MRI. Or it might be able to say, there's a problem in this general area, but it isn't precise enough for, say, planning surgery.
So this new paper, titled Intelligent Healthcare Imaging Platform, is trying to build a better assistant. What makes it so different?
The secret sauce is something called a VLM, or a Vision Language Model.
Okay, you've got to break that down for me. Vision Language Model.
It's simpler than it sounds. Think about how you use your phone. You can point your camera at a landmark and ask, "What is this?" And it tells you, that's the Eiffel Tower. It connects what it sees with language. This AI, which is built on Google's Gemini model, does the same thing but for medical scans.
So, it can look at a brain scan and not just see shapes, but understand them and describe them in medical terms.
Precisely. And it's what they call multimodal.
Another tech term. What does that mean?
It just means it's not a one-trick pony. It can analyze all sorts of images, CT scans, MRIs, X-rays, even ultrasounds, all within one system. It's a jack of all trades and a master of them too.
Okay, a versatile AI doctor's assistant. What else can it do?
One of the biggest things is precision. This system doesn't just circle a blurry area, it provides exact pixel coordinates for any anomaly it finds.
That's like someone telling you your lost keys are somewhere in the house versus giving you the exact GPS coordinates.
That's a perfect analogy. The paper found its system was accurate to within about 80 pixels, which is incredibly precise and super useful for doctors.
Wow. And I saw something in the paper about generating reports.
Yes, this is a huge time saver. After analyzing the scan, the AI automatically writes a detailed clinical report. It describes the findings, the location, the size, and even gives a confidence score, all in the standardized format doctors use.
So it's not just finding the needle in the haystack, it's writing a full report about the needle's composition, size, and location.
You got it. And to help the doctor visualize all this, it has a multi-layer visualization system.
Is that like having different layers in a photo editing app?
It is. The doctor can see the original scan, then click a button to see a neat sketch of the tumor's outline drawn on top. They can see an overlay or even a statistical heat map that shows the probability of an issue in a certain area. It gives them multiple ways to understand the data.
Now, I've heard that training AI takes a mind-boggling amount of data. Do they need to feed this thing millions of X-rays to get it to work?
That's what's so cool about this approach. It uses something called zero-shot learning.
Okay, that sounds like science fiction. Zero shot.
It kind of is. Because the system is built on a massive pre-existing model like Gemini, which has already been trained on a vast amount of general data, it doesn't need to be retrained from scratch for every specific disease.
So it's like a medical student who has read every textbook in the world and can use that vast knowledge to diagnose a condition they've never personally seen before.
That is the perfect way to put it. This makes it much easier to deploy in a hospital because you don't need a massive specialized dataset to get it up and running.
This is all fascinating. Can you walk me through the process? I'm a radiologist. I come into work, grab my coffee. What happens next?
You'd open this program, which the paper says has a simple, user-friendly interface. You just drag and drop your patient's scan, let's say it's a CT scan of the brain.
Okay, file uploaded. Now what?
Now, the AI takes over. In seconds, it analyzes the image, it identifies the anatomy, scans for any abnormalities like a tumor or calcification, and pinpoints its exact location. Then it populates your screen with all that information.
So I'd see the original scan, the different visualization layers I can turn on and off, and a draft report ready for my review.
Exactly. The report would say something like, lesion number 1, located in the right lateral ventricle, appears to be a choroid plexus calcification, with coordinates, dimensions, and a confidence level of, say, 10 out of 10. The doctor is still in charge, but their work has been massively accelerated.
So what does this all mean for the future of healthcare?
Well, the results from the paper are very promising. The system showed high accuracy in finding problems and generating high-quality reports. For doctors, it means a potential reduction in workload, faster diagnoses, and a powerful tool to double-check their own readings.
And for us, the patients.
It could lead to faster results from our scans, more consistent diagnoses no matter which hospital we go to, and ultimately, better and quicker treatment plans.
Of course, this is still a research paper. It's not in every hospital tomorrow, right?
Correct. The authors are clear that this framework needs more widespread clinical testing and validation. They also want to improve its ability to handle very complex cases where a patient might have multiple issues at once.
But it's a really exciting step forward. It paints a picture of a future where AI isn't replacing doctors, but empowering them to do their jobs better and faster than ever before.
Absolutely. It's about creating a partnership between human expertise and artificial intelligence to improve patient care. A pretty powerful idea.
Well, that's all the time we have for today. Thanks for tuning in to Daily Papers.
Join us next time as we unpack another fascinating piece of research.